to maybe pick your brains a bit more with respect to a question. Maybe I didn't put enough slides with respect to that, but you will see what I mean. And for the ones that are online, feel free to ask questions, to unmute yourself and interrupt, and to ask questions in the chat. The ones that are sitting there, I'm not sure I can hear you as well, but U10 might be able to go there. But feel free to interrupt. Yes, so I'm taking this as an informal kind of seminar that you have from time to time. Right. So one of the things that I've been looking at for a very long time is this idea of understanding urban systems from the perspective of how they are defined related to their connectivity. But of course, this problem very much relates to the scale at which you're looking at the problem. So first of all, there isn't a universal way to define all these systems. And secondly, it very much depends on the granularity of the data that you have. So sometimes, even though you would like to do better, you don't have the opportunity to do so. But what I want to motivate today is why it is important and how we can bring together different methodologies in order to be able to advance this area. Okay, so one aspect that I've been working for a long time is this idea of how do I define the boundaries of a city. So how would you define the boundaries of a city? So this is an interactive session. If I tell you, okay, go and look at cities, how would you define these boundaries?
Maybe taking a satellite image and
okay, very good. I don't know who said that, but yeah, so maybe taking a satellite image and looking at the urbanized space, right? And what would be the restrictions of doing that? If I do that, what could I be missing from this picture?
So for example, this is Rodrigo, by the way. So for example, I'm thinking of a case that I know, which is Mexico City, and for example, I've seen it with my own eyes, the border of the city, which is on the forest side, and people chopping trees and building their houses there, and that interface is kind of tricky to find out, right?
Okay, so I will do Mexico City today. That's a nice example. So what else could I be missing? So if I take satellite maps in the definition of a city.
Of the activity of people.
People, yeah. So that was one. I think, yeah. So people, right? So the people that commute to work, right? So one could think about defining cities in terms of population density. So for example, in order to make sure that you are considering the boundaries according to where people live, we could take satellite images in order to more or less look into this idea of the urban extent with respect to infrastructure. So what is the urbanized space? What is the intensity of the urbanized space? But of course, this also puts into perspective the idea of governance, right? So if we're thinking about an intervention in a system, then once we move out of these administrative boundaries, then we need to think about governance and how this intervention will take place. But of course, as was pointed out, what about, you know, the people commuting to work? So all these other urban interactions that are taking place. So one can think about the differences in adding all these areas from which people commute to work for certain purposes, while for other ones only leaving the extent of the urban system, right? And then you think about, well, what about city regions and so forth? So if you think just about neighborhoods, how do you go from these neighborhoods to your city and your city to the regions, and which are the ones that are going to be part of that? So why do we care in the first place, right? Because it could be that maybe it doesn't matter too much. You know, there are some measures that it really doesn't matter whether you're including or excluding certain things, but there are other ones that definitely will make a difference if you are including them or not. For example, anything that has to do with the coverage of an area, you could investigate whether bigger cities are greener or not. That has been done in the past with respect to this so-called scaling loss, right? But when you look at works like this, then of course you end up with the problem of, depending on what sort of aggregation and what are you considering, you can imagine that if you were to take green space, it wouldn't be the same to be taking only the urban core than to be considering as well all these areas from which people commute to work. So you could exaggerate the amount of green space that people are having just by taking into, I mean, this is CO2, this is different, but you can see how you would be able to get, you will be having two different type of assessments in your system depending on what you do. Of course, this problem of scaling and this type of issues have well been looked at by the group of Eduardo Allman with respect to whether actually there is kind of mathematical inconsistency when people are looking into these things. But let's not worry about that. The main idea is what you're considering in order to make claims like that is very much important. Then if we think about economic productivity, which is more or less this motivation of including workers. So if we look, for example, at New York, right? So you could say, okay, so we have a city of 8.8 million people, and you know, the income of these individuals is such or whatever. But then if you look at the metropolitan area, if you think about New York, you know, New York is considered like one of the biggest cities as well and so forth. And then you will say, but what do you mean by 8.8 million? Well, actually, because when one is thinking about New York, you're thinking about the metropolitan areas. So when you go back and think about all these other claims and about what is going on in a country, you very much have to be aware whether they're talking about metropolitan areas or they're talking about the urban extent of the city, because of course, these will be two very different things, right? And of course, sorry, just going in the other direction. And of course, another of the things that we looked at as well is related to innovation. So this is very problematic because, of course, where are you going to put your innovation? So this is one of the things that also we did a very long time, in which we're considering the urban cores. And then we say, okay, so if we're thinking about economic functional areas and we're going to try to include all these other people, which ones are you going to include? Okay, so I'm going to include a percentage of commuters, but what percentage of commuters? And so as you start to take into account bigger areas of commuters, you start to grow your cities. And maybe this looks okay, but as you go further and further, you can see that you might end up with a situation that is really not the case of having a system of cities, right? And so we kind of explore this in order to this type of idea of having, you know, models of many different cities and many different commuters in order to more or less see how much it matters or it didn't matter. And when doing so, the idea of having a concentration of, say, patents, which will be a measure of innovation, of course, they're going to say, oh, you know, it's not a very good measure. And there is a lot of discussion about why patents, it's not a very good measure of innovation. But let's say that it's one that you could consider. So by looking at where they are and not realizing, so if you don't look at the scatter plot, just look at the exponent. If the exponent is bigger than 1, what you're saying is that there is a concentration of innovation in bigger cities. And when it's very close to 1, is that it is proportional. So there isn't any concentration being observed. And when you're considering this type of systems, if you don't look at what is going on in terms of the outliers, you would very easily say, yes, you know, bigger cities are greener, they're more productive, and they're better for everyone, right? And when you look closely at the picture of what is going on, basically what you end up seeing is that the cities in the north, which are the post-industrial cities, are not performing very well, while the cities in which you have a concentration of universities or they are in a belt outside of London, you will have that there is a high increment of patents being listed there. If you then consider the commuter, you decide to define cities in terms of its commuting zones as well. So it means instead of having a city core, I'm going to then consider a metropolitan area. Then you observe that actually the concentration seems to be bigger than what you had before. They will say, oh, right, so actually, you know, like it kind of works. But again, when you look at what is going on, you see that actually the concentration, it's very much particular for these specific cities that are in there. And what you have in the left and in the right of your screen, looking at the difference, why are you going from a concentration in cities, you know, from looking at this exponent when in one case and not having in the other, is this idea of really what is going on at the level of measuring these things. Yes, in which if you cut, of course, all these cities and you do it in this way, then you're going to end up with just a line being more straight, so to say, more closer to one. Yeah, and of course, you know, this is something that Eduardo Altman looked at in detail in order to more or less see what was going on. But what is interesting to really note here is this idea of what is going on in these other parts, and why would it be that you will expect to have higher concentration in one place or in another one? So you see there are many intervening things going on in this case. So you would expect to have a higher concentration, maybe bigger cities, in the same way of why, you know, for example, I'm in London, but you will expect also to have a higher concentration in places like in Oxford, in Cambridge, in these places, because you have all these set of opportunities being there for you to be able to develop and innovate, right? So this is one of the issues of why one needs to be careful, and this is just to depict, depending on the definition of city that you have in this very crude way of trying to define the innovation, you will say whether bigger cities are or not more innovative. So in this case, as I reduce the population density and only take the course, the very center, the very course of the city, and I take all the commuters, I will be in this space over here. And in this space over here, I'm saying bigger cities are super more innovative. Well, if I'm more into taking a satellite image of a map, which will, of a satellite image of my cities and defining the urban boundaries according to that, I will be over here. I cannot see I will be over here. And as I go into including more and more commuters, I will see that actually it doesn't have such a strong effect in this case. Yes, because of all these other issues as we are talking about. I mean, in addition to that, you have to consider when we're considering innovation in terms of patents. Patents are not necessarily in the place. The innovation is not necessarily taking place in where the patents are being registered, right? So you will have the headquarters being maybe outside of the city because it's very expensive to have them there. And this is why you will have like these other corridors in which you will have the patents being registered instead of London, for example. Okay, so there are many other things to consider in these cases. And many of you working in the big project over there, you will also understand this issue of not considering everyone when you're taking, you know, arbitrary definition of cities. So you're leaving behind informal settlements and you're leaving behind the informal economy as well. So in this sense, of course, maybe the informal economy is integrated within the boundaries that you have decided, but you have defined, but of course, within the data set that you're considering, you don't have this type of information. So what to do in order to try to integrate these things? And of course, you know, it's absolutely essential if you are to define any design, any type of interventions, right? So when trying to understand cities, something very important that, for example, in all these other cases, when people were talking about all these scaling laws and so forth, try to see whether cities were performing well or underperforming and so forth, it was as if the cities were considering as floating drops of water in the system, right? Instead of being as things that will interact maybe more or less, depending on whether they're part of the same system or not, right? So that depending on whether they're in the same country or not. So not only is with respect to which element the city belongs to, which big system the city belongs to, but also about how integrated maybe is this or not. So one of the things that has been observed, as you might well know, over the years, is this idea that the city, as being part of a system, it's very much it follows certain regularities that have been observed over the years, and one of them is Zipf's law. So Zipf's law tells you that you have the biggest city, and then the second biggest city will be half the size of the biggest city, and the third city will be 1/3 of the size of the biggest city, and the fourth one 1/4, and so forth. So you have this power law relationship between the rank of the city and the population size of the city, and it's a regularity that has been observed, for many for centuries, so to speak, and it's something that it's there, like in everywhere in the world, So that's the claim, and that's the regularity that more or less you can say it's part of how urban systems work. So of course, people will argue, well, no, but actually, it's not a power law; it's a log normal, and there are many different positions with respect to how good statistical fit it is or not. And in a recent publication now, a year and a half ago, so we have this paper by Berbavatz and Mark Barthelemy telling us about why you would be observing this type of regularity. And so overall, the conclusion of this paper is that what you observe, so first, it is very, very difficult to be observing this exact Zipf's law. But overall, what is observed, if you try to create a model of why you would have this type of things. So first of all, the model needs to consider the interactions between these spaces. So the spatial distribution of where these spaces, these cities are, is very much important. And by looking at the interactions between these different places, one observes that it is the interurban migratory shocks that dominate this city graph. So without considering that, you wouldn't be able to really look into why do you have such regularities in these systems. Because of course, what is amazing is to be able to what we try to do in complexity science, of course, we try to see whether we can observe regularities that are universal everywhere. So we have cities, we have, of course, I don't need to motivate this because you're sitting over there doing more or less the same thing, right? But and you all kind of agree, yes, we're trying to find mechanisms that will drive the system towards a solution that can be observed everywhere, right? So taking into account not only the fact that the boundaries of these cities matter, because how many people you're going to be counting in order to produce these things, but it's also about the interaction between the cities is something that sometimes is left on the side of these things. And when you think about why you would end up having this type of regularities observed, you cannot consider that without taking into consideration how people are moving in your space. So why you will be having more flows going from one place to another depends on economic opportunities and many different types of things. So if you were then, instead of taking a satellite image to try to see, okay, so I'm going to define this importance of these places according to how people are moving, and this is a very interesting paper by the group at the FISC of Jose Ramasco. So what they tried to see is whether there was some sort of connectivity as well between this hierarchical organization of your system and the livability of your place. And just by looking at how people are moving into the space, you will be able to detect these hotspots and be able to more or less classify your cities and really look into that. So using of course, to be able to do that, then you go back into this idea of granularity of the data. So you have this data set in which you are able to really see how people are moving into your space and create this hierarchical structure. And more or less around the same time, you had another paper appearing in Nature considering exactly this. So if you were to look at mobility, I mean, mobility is one of these topics that have, like, I don't know how many different papers in Nature being produced, like, for a very, I don't know how many years, like at least a decade, being produced yearly about trying to understand how we move in our cities, we move in the space. And this paper it's very interesting because it tells you that if you are looking at the frequency, how people are moving into this space, you will then be able to define this the containers of individuals. So you will be able to define like their neighborhoods, their cities, and how they move across different places. And so you think about that and you're like, okay, so considering this, you should be able, maybe by mobility patterns, be able to define your cities, right? Because these administrative boundaries that we were defining before, maybe they're obsolete. And on the other hand, you consider, well, these people are moving with certain frequency and so forth, very much because of how the infrastructure is laid out and the opportunities that they have to do so. So then you cannot disconnect the mobility patterns that you obtain from the transport networks and so forth. And very much thinking about this type of patterns, so the probability of moving from one place to another one will very much be given by a reinforced path that has been done, over the years. So then by looking just at the morphology of your street network, of your cities, you will be able to detect these neighborhoods that are denser and come from, like this reinforcement that has been taking place over the years. So this idea of interaction, this idea of defining the city in such a way is not a crazy thing that that people are just proposing now. It's something that has been going on for a very long time. So how else will people be interacting? So you can also see it with respect to the intensity of the communication networks, and also work has been done for over the years. I think at the time that Juan and I were at Imperial, Yuka Pekka was one of the first persons that I heard talking about looking at these interactions of individuals through the mobile phone data. So if you were to look not only at the interactions between the antennas, but also the intensity of where these antennas are in the space, you can very much identify these spaces in which you will expect to have higher interactions of individuals, and maybe try to identify these spaces in which you will be able to pass better a message. Okay, so overall, we have been talking about all this idea of trying to identify the system in the right way in order to be able to make sure that whatever we're doing, we are including who we think we're including in our city. There are many different ways to define cities. I have worked a lot in terms of the street network. There are many different definitions out there, considering, for example, the urbanized space in terms of continuity. So if something is at least 200 meters of distance, one building from another one, which is like what France will be taken as a definition, then you consider it as part of the same urban continuum, so to speak. And there are many different definitions depending on what is that you're looking for. Most of the time, people consider that metropolitan areas are the ones for which 30% of people are going to be commuting to these areas. So this is more or less one kind of one way that everybody agrees, and so forth. And the European Union has been defining systems of cities in terms of functional urban areas as well. So you will be able to go and find definitions of cities that are consistent in principle with each other. There are lots of issues with these definitions, and we have worked as well a lot with those, and it's just important to understand the way they are constructed and what is the thing that is being left behind. But then when you go into Chinese cities, the whole thing is a bit more complicated, because you will have like the city plus all this other area that is not only what you would understand in terms of the urbanized space or the economic functional areas of people commuting to work. So you will have these very old definitions of cities that include all this other space and many other settlements. So the city is not only one city, it's many settlements being included in one that don't necessarily work in the way you would think about metropolitan areas. So this is just, you know, like just to leave you with these ideas. And so what I want to show you is why it matters, and the small project that we did for Mexico City, right? And this project was related to the problem of water. So Mexico City, you know, Tenochtitlan. So who is there? Is it Rafael that is there?
No, Rodrigo.
Rodrigo. Good. Okay, so what is going on with Mexico? So Mexico was funded on a lake, right? So you have Tenochtitlan, which was, you know, like a Venice of back in the day. So you have very different canals and so forth. So this is how it looked like when the Spanish arrived. So looking at a picture like this one, it's a bit crazy to think how Mexico, a city, now has problems of water, of course. And so by the time that Hernán Cortés arrived, you will have a picture like this one, you know. So you will have many areas of agriculture being connected to the main roads and so forth. Yes. So this is the picture of Mexico City, you know, back in the 16th century, with a population of around 200,000 people and so forth. And when you look at Mexico City today, the definition, the administrative definition of Mexico City is very much, sorry, so I have a mess here, my desk at home. Bring closer my stuff. Okay, so you will have this red, I don't know whether you can see the red area. So this is Mexico City, and all the rest is part of the metropolitan area. Okay. So as you can see, you don't see a floating city any longer. Yes. So you don't see a city surrounded by water anymore. So what is the matter with Mexico City? So basically, what is going on is that there has been an overexploitation of its aquifer. So you get all the water extracted. So you have a city that has been drained. So the whole what was the lake has been drained, and it has been drained exhaustively. And also what you have is that in the way the infrastructure has been constructed in order to distribute the water is something in which you have a lot of water that is being wasted and so forth. So it's not only at the level of the how, where, and how to extract, it's also how to distribute this water in a proper way. And you have water that has been polluted and so forth. So the water in the problem of water in Mexico City is really, really bad. Rodrigo can tell you. Are you from Mexico City? Yes. So he can tell you how. Well, you're much younger than I am, but you know, we grew up in Mexico being super careful with water. You know, it's something that you kind of is part of Mexico City, of your culture, if you grow up there. And so when looking at a problem like this one, we were asked to create something. So I was working with some sociologists, some people as well related to water, hydrologists, and this type of individuals. And basically, the what the project intended to do is to create this socio-hydrological index that will be taking into account the water stress, so with respect to all the physical things going on with where you can extract the water, how it gets replenished with rainwater and all these type of things, in addition to the adaptive capacity of the system. And this adaptive capacity takes into account not only all the environmental strains that you're going to be putting into the system, but also the social aspect of the system. So it takes into account the socioeconomical perspective as well with respect to this adaptive capacity. And so there you have these two systems in which you're, on the one hand, you're talking about, what is physically available in your space and so forth, and how it's been extracted and all this type of more engineering type of things. And on the other is the population that is down there. So when looking at a system like this one, for the ones that are interested, I can send you this link here, more or less tells you how the whole project was operated. But it was divided. So the index is constructed over many different layers, but mainly, as I was telling you, considering the level of pollution of the water, the scarcity, all these type of things, but also at the same time, the economic capacity, the human resources, and so forth. So you have these different aspects that need to be woven together. And of course, when you think about this type of project, and as Rodrigo will tell you, being from Mexico City, looking at this definition of Mexico City, it's a bit absurd, right? So when you look at this definition of Mexico City, it has only 9 million people. While if you look at the whole metropolitan areas, it's a bit the same issue as we're talking about with respect to New York. It has almost 22 million individuals. And so on the one hand, you could be doing the whole project for the whole of the metropolitan area. But on the other hand, you were proposed to do this in order to be able to talk to stakeholders and do an intervention. So what do? What sort of definition of city do you take into consideration, given the local politics of the area and so forth? So we first decided that in order to sort out this thing, we were going to look at the idea of defining the city with respect to what made sense in terms of the connectivity of the system, right? So if you're thinking about the socioeconomic problem as well, and you're thinking about putting an intervention that relates to a new kind of technology, you would like this intervention to be taken as well by your neighbor. So you would like an intervention to be seen by your neighbor as something that makes sense. And in order for that to happen, your neighbor needs to be similar to yourself, right? So then you start to see how, this idea of connectivity, not only with respect to connectivity, the physical connectivity of the system, but also the connectivity in terms of similarity, and be able to talk to your neighbor and so forth. So this is the way we decided to approach the problem. So how did we do that? So first of all, we considered this idea of the physical connectivity, as we have been doing it for many years now, in which we take the street network, and then we see how easy it is to navigate the street network. Most of the time, when you're thinking about the connectivity of a city or for a system, you consider public transport and you consider transport networks in general. We could have considered bus networks in this case. In Mexico, you have the underground, but you have an underground that doesn't cover, much of the territory that's of interest in this case, right? So the street network is very, very important. As for the bus routes, that's very messy. So for this thing, we decided that as a first approximation, we're just going to consider the possibility to be connecting one place to another one, through the street network, because the bus network was very, very messy. But of course, if we were to be looking as well as economic opportunities and something more, it will be very important to consider the bus network, which, I mean, it's so messy and there is so much traffic in Mexico that it can take you 3 hours to go from one place to another one, like the airport, for example. Okay, so by doing this type of experiment of just, connecting the city via the street network, you will see the largest clusters appearing in red, then blue, then green, and they're changing positions because as you start to connect the city, you will have larger clusters appearing in different positions. So what are we doing? We're taking the street network. We're simplifying the street network, so roundabout and everything is just collapsed to one point. Double carriageways is just one link, and we're saying that you're able to connect from one place to another with a link that is given by the distance of the street segment. Okay, and then we're applying this thresholding procedure in order to see. First, we're going to see at the very the links that are shorter, and then we start to be able to connect further parts of the systems as we allow for those links to have a higher distance. And so so this is more or less, sorry, what you obtain. Okay, I think this map is a bit funny, but so this is what you see. So what we took the Mexico City, and we took as well the metropolitan area to more or less see what was going on. Okay, and what we did at the same time, so this is for the connectivity of the city, and at the same time we also look at this connectivity with respect to the socioeconomic similarity, socio-demographic similarity, if you want. So this idea of proximity by homophily, if you want. So how did we do that? And this is where the problem of scale starts to bother a lot in this case, right? So you have the data given at the census area level, and that area, you cannot do anything about it. It's the minimum that in which you have this data set. So what you can do is to create then a centroid for this area, and then create the Delaunay triangulation in order to relate to your nearest neighbor. Okay, so you want to see how similar you are to your neighbor, so you create the centroid of your area, and then you create, maybe I'm saying things that you're very familiar with, I don't know. I'm thinking that you're in network science, but maybe dealing with something else and not spatial networks. I don't know. So let me know if I'm saying things that you're very well familiar with. So are you familiar with these Delaunay triangulations?
Not everyone.
Not everyone. Okay. So you see, when creating your spatial network, so you have your space divided into different segments. It can be grid. If you put a grid, in this case, we take divisions given by the census data, and then how you're going to construct the network. You want to see how similar you are with your neighbor. So these Delaunay triangulations is something that you do in one of these in Python. Okay, in Python you can create this. I think I did this one in Python, Delaunay triangulation. So it's packages. You don't have to worry too much about it. But mainly it's telling you, it's creating a link between your nearest neighbors. And so then what you have to do is to create a weight for this link. So how you're going to create a weight for this link? Well, you can more or less consider that things, like the first law of geography, there is such a thing says, which is Tobler's law, that things that are closer to you are more related to you. So that's why you're going to be looking at your neighbors, and also because you want this message to spread fast, and you're assuming that distance also plays a role in this case. So you can create a proxy for this similarity in many different ways, as you must have seen in your classes or in your research. I don't know whether you, because I cannot see you. You see, like I see you so far away. Anyway, so in this couple of slides that you will be able, you have, you know, like many different ways in which you could construct from two vectors. So what are your vectors? So you create a vector of characteristics. Thank you. Now I only see 3 of them. Maybe it was better. Okay. So you can create a vector of your characteristics of each of your centroids. Then you ensure whether you have they're independent. So you can do a PCA, you know, principal component analysis, in order to see whether your characteristics are independent or not. And then from those characteristics that you select, then you're able to create a measure of distance between these two things, right? Which is, you know, in this case, we did a distance through cosine similarity. Yes. So, well, you have to standardize your variables and so forth. So you have that, and now you have a link that has a weight with respect to how similar these two spaces are with respect to the people that live in those, right? And of course, here you have the same issue as we were saying at the beginning. The characteristics that you're going to have in those spaces relate to the ones that are in the census, right? And so you're leaving behind many of the ones that are not in the census, right? And so, for example, if you wanted to fill in data, you know, you could think about this idea of whether you could fill it with being similar to your neighbors if the data is missing for some reason. If it is because you have informal settlement, then of course it's a different issue, right? You have to be careful about what to do with this type of things. So to cut the story short, you know, these type of things, if you were to look at the proximity of the different areas according to the infrastructure, you get something like that, right? So depending on how the length of your network. Sorry, I forgot to tell you. So in this case, I'm only plotting the largest clusters. It doesn't mean that the others don't exist. It's just the largest ones that have color. And then you look at the socio-demographic proximity, you get something like that. Apologies for the quality of these maps over here. But the first thing to notice is how these areas get integrated straight away, yes, into the rest of the system. And with respect to socio-demographic proximity, you also get, you know, these areas being connected and so forth before some other areas. Yes, so this is important. So you have before some other areas that were considered. So in black, you have the delimitations of what is Mexico City. So before other areas join, you already have these ones that have joined with respect to infrastructural connectivity and with respect to socio-demographic connectivity. So I should have put more slides in here to ask you to pick your brains, but you can come and talk to me afterwards if you get this idea. So on the one hand, you have a cluster that is given by the infrastructure, yes, and on which is very granular because you're building this cluster out of the point of intersections and the street network. So it's very granular, you have that. But then on the other side, you have another cluster that you are constructing according to this socio-demographic proximity, but that is given by the granularity of the unit of geography at which you have the data. Yes. So how do you put these two together? Yes. So that's a difficult issue. That if you want to work on this, let me know. If you have any ideas how to sort it out, let me know. And what did we do then with all this mess? So basically, by looking at these areas, we really thought it was important to include this area here and these other areas here that were not part of Mexico City. So basically what we said, let us extend the definition in a minimalistic way, okay? So to include just the ones that really seem to be very much connected to the city and cannot be left behind. So one of those ones, those areas that get connected straight away in the system is Ciudad Nezahualcóyotl. So Ciudad Nezahualcóyotl, it's the city of Nezahualcóyotl, right? So it is considered as a different city, but as you can see, it is completely connected to the system, and it has 1.1 million people. So this area here, only this one here, I mean, I have this one. This has 1.1 million people. It is absolutely insane. Looking, so Rodrigo cannot say anything, but looking at this picture, do you think this is a wealthy area or not? Well, not wealthy. It's a normal Mexico. I mean, like, we're not going to say Mexico is wealthy, but like, is it in which spectrum, in the towards the wealthy or towards the deprived?
Very poor.
Sorry.
I guess it's quite poor.
It's quite poor, right? Yes. So you can see straight away there are no green spaces. It's very regular, and this part of the city was one of the last parts too. So it was part of the Lago de Texcoco, which was a lake that was one of the last ones to be dried, and then they start to sell it in small plots. So this is why it's so regular. And maybe Rodrigo knows more about this urbanization process in here. But it was sold in small plots straight away with no water or so forth. So it's a part of the city that is very much deprived, and the services are almost non-existent. So this is one of the things they say, okay, yeah, but it's another city. Well, it's not really another city. You cannot say that this is another city in terms of how it influenced the rest of the city. So are you going to leave it behind for your intervention, or are you going then to say, this is a city that lacks services and I'm going to include it? You know, because it's very connected to my space. All the space in red are the spaces that were added to our definition of cities because of that. Okay, yes?
No, I think that just says the noise.
Ah, okay. Yeah, it's like this surreal sketch when some people are in person and some are in the virtual space. So when for the ones that wants to investigate these tools, so I have here a few slides, but overall, what we observe, if we try to more or less quantify this idea of social hydrological vulnerability, you will see that these spaces that were added were one of the ones that were most deprived. So very important to consider them, because if you have overall, what you have is a limited budget in which you can implement these technologies, and these technologies related to these things that are called constructed wetlands. So these wetlands are able to clean the water, and you're also able to use these technologies to plant things, and then people sell the flowers that are planted. So you're able to clean the water, because the issue of and to capture rainwater and so forth. So it's a way to treat water overall. So overall, if you have limited budget to construct these things, where are you going to put it? How are you going to spread it into space? And how are you going to make sure, for example, that people are going to be willing to have them, right? So I'm running out of time, so maybe I'm not going to explain too much about these things, but you can see that the areas that were left behind at the beginning are the ones that are in very much prioritization of where you would be putting this budget. So depending on the amount of budget that you have is where you're going to put it. So I'm showing you this, even though it might not seem as the forum here, in order to see how you can then take your models and take the things that you're constructed for cities, for example, and be able to talk about these things with stakeholders, right? So if you put an amount that you you put an amount of money maybe that you have in order to construct these things, and you see where you can put them. And as you increase this budget, then you will be able to put more and so forth. Okay, so to conclude, basically, there is not a unique way to construct cities, to define cities. So depending on the problem that you have, you might be looking at the very urbanized space, taking satellite images, for example, as was being proposed, or you might be thinking about the economic functional areas, and so you take commuters and so forth. But depending on the problem that you have is how you're going to be defining your cities. And the administrative boundaries, even though they might be obsolete in many different cases, the data is very much related to these administrative boundaries, and the stakeholders are very much also related to these administrative boundaries. So how to cross all these things is something that needs to be investigated in the particular case that you're looking at. So many times when you're constructing your systems of cities, not only within the definition of the city you're leaving people behind and or being considering informal settlements and so forth, but also when you're talking about your models of cities, most of the time it's about the 100 biggest cities, and the other ones are being left behind. Then if you think about connectivity, you might think when you're modeling your cities, most of the time you might be modeling your cities with respect to your own country, right? And you might be seeing what happens when you're applying these models to your own country. But the connectivity might be closer. For example, if I think about London, right? I think modeling London, if I have a model of Liverpool, it might not be as accurate than a model of New York or of Paris or another city that might have different, more similar types of activities than the ones that I'm going to have in smaller cities, for example, the financial system. Yes, and so in this sense, the connectivity of how you're going to be building your systems, the connectivity of your system plays an absolutely essential role in order not to have these drops of water floating in the space, but connected to the rest. Yeah. Okay. So the appeal, the appeal is now to be able to go from one scale to the other one when you're considering different types of connectivity. It is easy to consider different types of connectivity if you have multi-layer networks and you have your nodes at the same scale. But once you start changing the different scales, and one is not necessarily the agglomeration of the other, then of course that's where the main issues start. And just to finalize, so these are the people in black and white or more architects with whom we work with this constructed wetlands. Some of the social scientists are not here, and then this the rest of the people that have all been at CASA on some time or some point in time or another. Thank you. I think I only left 2 minutes for questions, but
Well, thanks for interesting talk. Do we have any, since we are proving 3, probably we can do 1 to 2 quick questions. So do you have any question from the room?
I will try. So Elsa, can you hear me?
yes.
Yep. So thanks a lot for the talk. So I had a question about scaling laws, right? Because usually in scaling laws, what we want to do is to look at the relation between an average quantity inside the city with its city size, right? But clearly what you show is that there is a lot of heterogeneity in cities. So does it make any sense to measure what is the total number of something instead of maybe looking more at a distribution of, let's say, the green areas inside the city? But it seems like just looking at the total number would be like the average, and because of the huge variability, maybe the average wouldn't be very significant.
Yes, I completely agree with you. I really think that there are 2 main limitations of this scaling law. So first of all, you overlook the fact that if you have a city in which everybody is equal and has the same salary, Yes, and you do your scaling laws, and in your all of your cities you have equality, for example, and you might have an exponent, and you say, okay, well, the people, but you have a concentration, you have higher salaries in bigger cities, and you will have, you know, an exponent of 1.05, right, which is low, but anyway. Then to have exactly what we observe in most of the cities, in which you have a Pareto distribution of, say, salaries, in which you have that 20% of the population has 80% of wealth, and that is absolutely not considered in this scaling law. So I absolutely agree. You know, it's looking at performance of cities within the scaling laws by looking at how far they are of the expected behavior. I think it's a very weak way to realize that. Adrien Salah, who is now at the Alan Turing Institute for his PhD, so he developed this multifractal methodology to be looking at inequality in this way. So the heterogeneities in the system can be given by where things are distributed, but also what is the difference between this distribution. So you have the distribution, say the distribution of wealth. Yeah, so you have this Pareto distribution that it's a power law distribution as well. So you have this Pareto distribution of wealth, but then is it also homogeneously distributed in space, or is it concentrated in certain parts? So you have these two types of inequalities to look at, and using this multifractal analysis, he was able to more or less couple these two things. But yeah, I agree. You know, like I hope. I was trying to show the shortcomings of using these power laws, because it's not only that, it's also depending on how many you take, you know, what you observe. And so if you remove the small ones where you don't have innovation, then everything seems to be working fine.
Okay, thanks.
Right, thanks. Do we have another quick question? Oh, so I don't see any question from the chat.
Sorry.
Okay, there's
Yeah.
one. Matthew, please.
Hi, can you hear me?
Yes, hello, Mate.
Hi, hello. Hi, I have a question actually concerning your take on the definition of cities using commuting data, because you were mentioning that, for example, one way in which you can define the boundaries of a city is by considering how many people commute into that into the city, and there is it's an arbitrary threshold such as 30%. And yes, I wanted to hear your take on the limitations of this definition concerning, for example, areas that are kind of in between two cities, for example, where commuting patterns may be such that a large percentage of the population of this area commutes to one city and another high percentage to a city nearby.
Okay, so the first thing when people do these things, so they take the area and then they consider the largest flow, and it is where the largest flow commutes to. So it is indeed the case that an area might have if it has at least 30% of the population going to an area and the other one is dispersed in many other ones, it will get, you know, attached to this urban core regardless. But if you have, of course, the issue of, say, 25% and 30, so you're wrongly adjudicating, you know, this area to this other one when you have a a very strong relationship with other systems. Valentina Marin just recently published a paper in which she's trying to understand. Basically, what she's trying to understand is the structure of the country and the vulnerability of countries according to where people go to work to, the amenities that are available, and so forth. And she recently published a paper with respect to these commuting flows and looking at the northern powerhouse in the UK. So this issue of what happens when you have a monocentric city, you know, it's very much straightforward to see this. But what happens when you're considering polycentric cities, and what happens to the resilience of the system as well when you consider that type of things? So of course, yes, all these things have limitations. And for example, for green space, people take this commuting boundaries as part of the city, when it's not the case. You're not going to take this rural space from which that is, like from which most of the people are going to come into the city as part of your green space, for your well-being in a city, which happens. So yes, it's problematic.
No, it makes perfect sense. Like, I'm thinking about Rome and the whole countryside and archaeological findings in all the surrounding areas, but they're practically inaccessible to the vast majority of people from the city itself. It's just that they happen to be in the larger commuting.
Yes, exactly. So if you have any insights about this idea of linking the different scales with networks, let me know.
Okay.
Brilliant people over there.
Right, thanks.
Thank you.
And also the answer. Since it's already 6 past, I guess that's the end of today's seminar. So let's thank Elsa again.
Thank you for coming.
See you next week.
Thank you. Bye.
Thanks. Bye.
Stephen, you're there. I didn't see you.